All right, the general form for a conic section, okay, has a lot of letters, and it goes like this. AX squared plus B, and then a single x, a single y, plus CY squared plus DX, a single x. What else do we need? Okay, a single y, and E is the coefficient. So we've got 2x's, 2y's, one of each, both of them. How about a constant? Maybe 2, but maybe just f, okay, equals to 0. So that is the general form. Now, you don't necessarily have to have all of these letters. What if we just had a single y and an x squared? Y equals x squared. What shape are we talking about? A parabola, okay? What if we have an x squared and a y squared and a number? Maybe a circle, maybe an ellipse. Depends on if that's a plus or a minus, right? Okay, so this is how you make the conic sections with a variety of letters. So today we're going to investigate circle. A circle is the set of all points in a plane. The set of all points in a plane. So of course it's a bunch of points in a flat surface at a fixed distance. God bless you. At a fixed distance. What's that distance going to be called? Radius. Radius. Okay. All the points at a fixed distance from a fixed point. Fixed point is called the center. Okay, and so here's an example of a circle. We've got the center right there at HK. You go R units point, R units point, R units point. All of these points together form a circle. Standard form for a circle, here's the equation. X minus H quantity squared plus, now we need the Y. Y minus K, close it up, quantity squared equals R squared. Okay, so they're all squared, squared, squared. The center is HK, so you have to change which one? Both of them. Both of them. It's going to be change for H comma K. So if it's X minus 2, it would be a positive 2. The radius is just R. So your H and your K come from these things right there. Don't forget to change both of them, and the radius is going to be square rooted. Okay? The hard part's not graphing them. It's usually putting them in standard form. And in order to put them in standard form, aka do what? Complete the square. Absolutely. Complete the square. Okay, so to complete the square, maybe we'll put the x terms next to each other, x squared plus 6x, and I'll leave some space. And then let's put the y squared minus the 4y next to each other. What about 12? Where should I put that one? Let's move it to the other side, make him a positive 12. Okay, are we ready to complete the square? In other words, is x squared alone? Okay, so half and square it. Okay, so add 9 to the left. Add 9 to the right. Some people say, well, shouldn't I add and subtract? Well, not if it's two sides. What you do to the left, you do to the right. That's why it's add, add. If I did everything on the left, I'd want to balance it out by adding and subtracting, which we've done before. All right, let's complete the square for y's. Half of negative 4 squared. Plus or minus? Is it always plus? Why? Because you're squaring, okay? I just added 4 to the left, so I will add 4 to the right. And now it's that fun factoring time. X plus 3, quantity squared. Let's factor the y's. Y minus 2, quantity squared, equals, hurry, somebody that's smart with numbers. 25? Okay, a couple of questions I have for you. Where is the center of this circle? -3, 2. What is the radius of this circle? 5. Radius is 5. Those are the only two things you need to know in order to graph a circle. So let's go to -3, 2. So here's the center. Is that point on the circle? No, it's on the circle. The radius is 5. So let's go 1, 2, 3, 4, 5 to the left. 1, 2, 3, 4, 5 to the right. Let's go 5 up and 5 down. Okay, even if you're an ugly grapher, I'm not going to take off points. Okay, try to make it as perfectly circular as you can. Please don't draw it like a square. Okay, try to make it roundy, but as long as your points are in the right places, you'll get full credit. So I'm going to be grading these points, make sure that I can see them clearly. Any questions on circles? Okay, we're good with that. Eccentricity. This is a positive number that defines the shape. A positive number that defines the shape. And that's going to make more sense as we go through each of the conic sections and we talk about the eccentricity. For circle, all you have to know is that a perfect circle looks like this. So what's the number for his eccentricity? 0. Eccentricity of a circle is a perfect 0. What if you calculate the eccentricity and you get 0.2? Is it a perfect circle? No. What shape would it be? An ellipse. So what I need you guys to do now is try this circle problem, complete the square, find the center, radius, and graph it right here. Please pause the video, do that, and then go back to the video, turn the page, and we're going to continue our study with the shape of the ellipse. Let's take a look at the ellipse. The first thing we always do is take a look at a definition. So the definition of an ellipse, all the definitions start off the same way. The set of all points in a plane. The set of all points in a plane, comma, the sum of whose distances from two fixed points, and those fixed points are called foci, okay, comma, the set of all points in a plane, the sum of whose distances, the sum from 2 points, is constant. That's going to make a lot more sense when we actually build an ellipse tomorrow, and then we could touch and feel what we're talking about here. So the standard form of an ellipse has an equation, okay, and this is how it goes. We have x minus h quantity squared. So your x variable is squared, plus y minus k, the variable is squared. Okay, and this equals 1, and under each of these, usually like with a circle, we have a number here, but the numbers have been divided. And what happens is we get r sub x squared. So there's a radius for x, and then there's a radius r sub y squared. Different r's. There's a radius in the x direction and a radius in the y direction, and those are squared. So the radius in the x direction we call r sub x. So going left and right in the x direction, there's one radius. Might be bigger, might be smaller. The radius in the y direction is r sub y. Again, might be bigger, might be smaller, but they're different in size, and that's how you get the shape of an oval or an ellipse. The center is h comma k, and they're both change. Okay, let's take a look at this first one here. Maybe you can tell me what you notice. So first of all, this is already in standard form. It's already in standard form, equals to 1. They're both squared, and there's a plus sign. So this is an ellipse. The center, since there's no numbers there, is at 0, 0. R sub x, radius in the x direction, make sure you square root, that would be a 5. And r sub y, since that's squared, would be a 3. So let's go draw this. The center of the ellipse is at 0, 0. Okay, you can put a dot there if you want, but the shape is actually going to be going around. We have 5 units to the right and 5 units to the left, right there on 5s. And r sub y is 3, so we're going to go up 1, 2, 3, down 1, 2, 3. Okay, and here's the shape of the ellipse. Curvy, curvy, round. Please don't draw a pointy diamond shape. As curvy as you can. It's okay if it's a little off or ugly because I'm going to check those points. Okay, so as long as you're the correct number of units. Now the length of the major axis. The major doesn't mean x or y, it means who's bigger. In this case, the bigger one is going left and right. So the length of this axis, 5 to the right, 5 to the left, would be 10 units. The length of the smaller one, the minor one, 3 up, 3 down, would be 6. And that's how you do an ellipse. Okay, what do you do if they give it to you in this form and you have to put it into standard form? Then we're going to have to show some completing of the square. So let's write down this problem. The first thing I'm going to do is maybe put the x terms together first. So let's write 25x squared. The next x term would be minus 200x. Okay, so there's all the x terms. How about the y terms? We have a positive 9y squared and a positive 18y. And I think I'm going to put this constant number to the right. So equals negative 184. Okay, are we ready to half and square? No, not yet. Remember, when you complete the square, you have to get the x squared term alone. So the first thing we're going to do is to divide both of the x terms by 25. So that gives us the quantity x squared minus 8x. Okay, and I'll leave some space. Let's do that here for the y's. You're going to have to factor out a positive 9, and that gives you y squared plus 2y, leave some space, equals negative 184. All right, I'm going to work on the x terms first. Half of negative 8, and then squared is a 16. So how much did we just add? Not 16, but the number in disguise is 400. So we added 400 to the left. We'll have to add 400 to the right, since we're doing left and right. Okay, half of 2 is 1, squared is 1. Did we just add a 1? Well, not really. We added 9 in disguise to the left, so I will add 9 to the right. Okay, now we're going to go ahead and add these together and maybe factor right away too. So we have 25 times the quantity x minus 4 squared plus 9 times the quantity y plus 1 squared. And the sum of all these numbers is 225. Okay, I'm going to try to save the nice numbers for the test and maybe put all the bigger numbers like on your homework and stuff. So if you need to use a calculator for adding, I understand why, but we're not going to have calculators for the test. Okay, let's divide each of them, all 3 terms, by 225, because remember you have to make a 1 here. 225. Okay, so this cancels out. Does 25 divide into 225? Yes, it goes in 9 times. Okay, make sure you put the 9 in the bottom. 9, oh, look at that, does go to 225, and I know it goes in 25 times. So the simplified standard form here would be x minus 4 quantity squared over 9 plus y plus 1 quantity squared over 25, and that equals to 1. There we go, standard form. People tell me this is where they spend more time doing work than the actual ellipse graphing. Okay, so let's answer some questions. Where's the center? Don't forget to change. The point 4, negative 1, use parentheses. R sub x would be just a 3. R sub y would be a 5. Okay, remember, R sub x is under the x's, R sub y is under the y's. Can anybody tell me the length of the x-axis? Even though we don't see the picture yet, I know R sub x is 3. So 3 to the left, 3 to the right. So yeah, it would be 6. And the length of the y-axis is going to be 10. So looking at this, is the oval, is the ellipse going up and down, or is it going left and right? It's a little longer going up and down. So this is how it's going to look. All right, let's go graph it. The center is at 4, -1. R sub x is 3. 3 to the right and 3 to the left. R sub y is 5. So we go down 5 from the center. From the center, we go up 5. And I'm going to try to draw a nice rounded ellipse. Nice and curvy. Try to hitting all those points. Okay, try to draw curvy. Do not draw pointy ones. Okay. Now that we know what an ellipse is, let's talk about the eccentricity. Remember, that's a number that kind of defines the shape. And here's how you can calculate the eccentricity. Okay, so for that last example, I need to know the major and the minor. So R major and R minor. Okay, sometimes the major is X, sometimes it's Y. But in that last example, which one is bigger? Well, the 5 is bigger. So the major in this case was 5, and the minor radius, the smaller radius, was 3. Okay, so let's see what it says to do here. The calculation for eccentricity. Eccentricity says you have to do a big square root, okay? The major 1 squared, that's going to be a 25, minus the minor 1 squared. The minor 1 squared is going to be 9. And then divide by the major. The major is 5. So our eccentricity calculation here is going to be the square root of 16 over 5. So the eccentricity is 4/5. 4/5. Okay, and I'm just going to give you a little note here to make sure you get these right. Okay, the eccentricity of the ellipse, could it be 0? No, it can't be 0 because then that's a circle. So the eccentricity of the ellipse is always going to be between 0 and 1. Okay, 0 means that it's a circle, and 1 means that it's a parabola. But if you are between 0 and 1, then you are definitely an ellipse. Okay, the last thing we're going to look at here is writing an equation. Okay, and the best thing we can do is draw a picture. If you have a picture of the information, you will be 99% more likely to get the problem correct. Okay, and that's a very statistical analysis that I did. Okay, find the standard form of the equation of an ellipse. Okay, got it. The major axis has endpoints here and here. Okay, let's draw a picture. So we've got 8, -1. 1, 2, 3, 4, 5, 6, 7, 8, -1. So there's one endpoint. -2, -1. There's the other endpoint. Okay, and that's the major one. That's the bigger one. The minor axis has length 8. Well, if it's going this way, there's a couple of things I know. The minor axis must be going up and down. So this must be the R sub y. Okay, so let's look at this. Looking at this picture, if you know that the end is here and here, you should be able to find the center. Okay, some people like to do midpoint calculation. Some people just like to take their fingers and go in. 1 unit on each side, 2 units, however you want to find dead center. The dead center is right there. The center, C for center, is at 1, 2, 3, -1. The center is at 3, -1. Okay, now I know that the ellipse has R sub x, 1, 2, 3, 4, 5. 5 units to the right. Let's just check 1, 2, 3, 4, 5 to the left. So R sub x is 5. Now it says that the minor axis has length 8. So if the length is 8 from the bottom to the top, what's R sub y going to be? Not 8, but 4. Okay, when you're writing the equation of an ellipse, there's 3 things you need to know. The center, the r sub x, the r sub y. All ellipse equations come in standard form, and they look like this. Quantity squared plus quantity squared equals 1. And there's 2 numbers down there. This is how all ellipse equations look. Now all we need to do is put the information in. So let me give you a second to fill that in before I tell you the answer. Okay, I hope you remembered about change. It's going to be x minus 3. It's going to be y plus 1. R sub x is 5, so I hope you put 25 down here, and 16. Can you write the equation of an ellipse given information? Yes, you can.